Hello, welcome to this film about electron configurations, which is, I suppose, the last of the first week's films in Year 11. Hopefully you've understood everything up till now. If not, you should probably go back and make sure you do before you come here. Maybe ask a few questions as well, if you need some help with it. But anyway, here we go. This one's about electron configurations, and hopefully by the end of it, you'll know what we mean by a group and a period in the periodic table and what it's got to do with the number of electrons. You'll be able to write electron configurations for the first 20 elements. Don't have to worry about going past that, even in Year 12. And you need to consider what kind of ions an atom would like to form based on its electron configuration and then write an electron configuration for that ion. Okay, so here we go. How many electrons are there in an atom? This should be easy by now. And we get it from its atomic number, from an atom's atomic number, that is. So let's take titanium for an example. Doesn't matter that we don't have to do titanium. We can see that it's got an atomic number of 22, so there'll be 22 electrons in titanium. Okay. Calcium, which we do have to be able to write an electron configuration, has 20 electrons. Okay, so whatever the atomic number is, that's going to be the number of electrons, as long as this is an atom we're talking about and not an ion. Now, it's absolutely crucial to know how many electrons fit in each shell if you're going to write electron configurations. But we tell you a couple of little fibs in Year 11 and 12, just to keep things simple, and really because you don't have to go past element 20. Okay, and the fibs are in the third and fourth shells. These are absolutely true, no falsehoods here. Okay, there's 2 electrons can be put in the first shell and 8 can be put in the second. We pretend, for the time being, because we don't have to go past calcium, that the third shell only holds 8. In actual fact, it can hold 18, but it won't hold more than 8 until you get past calcium, which we don't have to do. The fourth shell isn't important how many electrons it holds at all, even for the problems we do in Year 11 and 12, but in actual fact it holds 32, just out of interest. But you'll never need to know that. Not until you go to university, at least. Okay, now group number in the periodic table. Group number is the number of the column that an element is in, and they're numbered 1 to 18. They used to be numbered 1 to 8, and that's because these groups didn't used to get given numbers here. So it used to be 1, 2, 3, 4, 5, 6, 7, 8. Okay, but nowadays it's 1 to 18. So group 13 is the old-fashioned group 3. The group number tells us how many electrons are in the outer shell. Okay, valence is just another word for outer, or at least it is in this context. It's not the case that you can always swap the word outer for the word valence, but you can when you're talking about electron shells in chemistry. Okay, so the number of outer shell electrons is equal to the group number, but for this rule to work, we have to call these groups by their old-fashioned names. Okay? So that's just for the rule to work. We actually call these groups 13 to 18, but for this rule to work, that group number equals number of valence shell electrons, we call these 3. Okay? So an atom in group 14 has 4 outer shell electrons, an atom in group 2 has 2. What does the period that an atom is in tell us? Well, first of all, what is a period? A period is a row in the periodic table. So here's the first row from hydrogen to helium. Here's the second row, and so on and so forth. Okay, so they're numbered 1, 2, well, I think there's 7 periods at the moment in the periodic table. Maybe one day when we discover more elements there might be more, but for the time being there aren't. I've just shown 5 here on this diagram. But anyway, the period number, quite simply, tells us the number of shells. So lithium has 2 electron shells. As we know from its group, it's got 1 in its outer shell. Okay, so a second key point to remember. Very important, but very simple too. Okay, so now if we put these things together, we should be able to write electron configurations for atoms. So, start off, remember, number of electrons in total. Here's boron. It's got 5 electrons in total, and it's got 2 shells because it's in the second period, and it's got 3 in its outer shell because it's in group 13. It's got 5 electrons altogether. If you can only put 2 of them in the first shell, then you've got 3 left to put in the second. Second holds 8, so there's no problem with fitting them in there. It's got 2 shells, second period, 3 in the outer shell, 3 in the outer shell. Let's take another example, maybe calcium. Okay, calcium's got 20 electrons. We can only put 2 of them in the first shell. We could put another 8 in the second shell, but we've still got 10 to go. So pretending that only 8 fit in the third shell, we'll put 8 in the third shell. That leaves us with 2, because we've got 18 so far. We've got to get 20. So 2, 8, 8, 2 is the electron configuration for calcium. So this way of numbering with commas in between is writing an electron configuration. It's saying that there's 2 electrons in the first shell for calcium, 8 in the second, 8 in the third, and 2 in the last. Let's look at what this tells us about the number of shells. There's 4, 2 in the outer shell, so we're in the 4th period and in the second group. Okay? Simple, but once again, if you don't know the rules, it's impossible. Learn those rules. Let's try some ions. Okay, I'm just going to choose a couple at random. Let's go for one that we haven't seen on any of the films yet. Let's go for a P3- ion, or a phosphide ion. Okay, phosphorus has 15 electrons. A phosphide ion, which has gained 3, is going to have 18 electrons. 2 can go in the first shell, 8 can go in the second. We've used 8. Can the third shell hold the last 8? Yes, it can. So that's the electron configuration for a phosphide ion. Notice that phosphorus, when it gained electrons, gained 3 to get a full outer shell. Let's try it with an atom that loses electrons. Okay, let's take magnesium as our example. Okay, magnesium with 12 electrons. Magnesium is in group 2. Magnesium wants a full outer shell. It could gain 6 electrons, but it would be easier for it to lose 2. There's another key point. You will try and do what involves least electrons. So magnesium usually has 12, 2, 8, 2. Magnesium ions want to lose 2 electrons to get a full outer shell. This shell is full. If you lose these 2 electrons, you've got a full outer shell. A magnesium 2+ ion has a full outer shell, and there's its electron configuration, 2, 8. What you should notice about most ions is that their electron configuration will be the same as a noble gas. They'll have achieved a noble gas configuration by getting that full outer shell. So that's it for electron configurations. Practice a few from the sets in the book. Should be quite easy, and if you've understood everything up until now, well done. Good luck with the rest of the things that you study.